Hello students, welcome to the fourth chapter of class 11 maths, which is complex numbers. Complex numbers, right? You must have observed a pattern that since class 4, 5, 6, 7 up to class 10, the first or the second chapter are always regarding a new set of numbers. Earlier you learned about whole numbers, then natural numbers, integers, rational numbers. When you came to class 9, you learned about irrational numbers, which was a new thing at that time. Irrational numbers, and then we elaborated it to class 10, which is real numbers. है ना? So, till class 10, we had learned the largest set being real numbers. So, real numbers, you have already learned till class 10. What was the thing? We always have some restrictions in a particular set so that we evolve to get a new set. Like in integers, we could not make a division. So that's why we evolved a new set, which is rational numbers. Then in rational numbers, we could not get perfect decimals or terminating decimals. Then we evolved with irrational numbers. So if you remember, like in class 10, when we had learned about finding discriminant, ax square plus bx plus c. This is the standard form of a quadratic equation. I will first tell you how did we evolve this complex numbers, how we got a new set. What was the restriction in the previous set? Real numbers, which we could not complete as a set. Then we evolved a new set. So this is the standard form of a quadratic equation. You had learned to find D, discriminant, which is b square minus 4ac. D, actually, D tells us the nature of the quadratic equation, what type of roots it will have. If D is greater than 0, then we have greater than equal to 0. Then we have real roots. If you remember, we had learned that D is less than 0. Then we used to write there are no real roots and we could not find them, right? So this was a restriction. And why did it happen? Because when we have to find the roots, we have to find square root of D. If we have negative 4, negative number in the square root, we could not calculate this value. Now this restriction gives us another system. That means when we have negative roots, what we can do? Here we have got a new value. Square root of minus 1 is assigned a new, you can say it is a new constant, iota. This is called iota, right? And its value is equal to square root of minus 1, which we did not learn earlier till class 10. So if we have root of negative 4, that means you can write this as root of 4, square root of 4 multiplied by 1, which is ultimately equal to square root of 4 into square root of minus 1. This is 2. And just we learned that the value of root of minus 1 is iota. Now this is the new thing that you are going to learn, and we will be dealing with this chapter in these two videos, right? So this is iota. The value of I is square root of minus 1. So first of all, you should know different values of iota. Like iota is square root minus 1. If we take square of this, this becomes square of, which is minus 1, right? So iota square is minus 1. What is iota cube? It is iota square into iota, right? Iota square is minus 1 into iota, that is minus iota. Then we have I4. I to the power 4 is I square raised to the power 2. I square is minus 1. Minus 1 square is 1. So first of all, you need to remember these values. This is one value, right? I'm writing it here, right? I square is minus 1. I cube is I cube can be replaced by minus iota. And I4 is finally equal to a positive number, which is. So sometimes you get an MCQ in the paper. What is the least value of n? So that in is 1. So in is a positive number. A positive number to see. Here we have negative number. Here we have negative I. So this is n is equal to 4 is the least value of n for which you get a positive value. Right? So here you need to learn how to, let me take one question to simplify. This is I to the power 30, I to the power 40 plus I to the power 60. Find the value of this, right? Evaluate. What we had just learned is when we take the multiples of 4, the power will be, the value of that I will be 1. So what I can do is I can break this 30 into multiples of 4 and then see what is the remaining value. This is I to the power 4. 30 is what? 7 times 4, 28 plus 2, right? 40 is what? I to the power 4 raised to the power 10. 60 is what? If we divide 60 by 4, we get 15. So this is 15 times 4. This is 10 times 4. And here it is not exactly multiple of 4. So I just broke it into 24 and 2, right? 28 and 2, 30. So 4 times 7 is 28 added to 2, 30. Now what I am doing is I am replacing iota 4 by 1. 1 to the power 7. What is iota square? It is minus 1. This value is 1, 1 raised to the power 10, right? This is 1, 1 raised to the power 15. Now you can solve it. This is negative 1 plus 1 plus 1. So 1 is the answer, right? This way you can resolve different powers of iota and see. Okay. Now next is, what is a complex number? See, I is a new value that you have learned. Earlier, like you had learned about pi. Pi is a constant and its value is 22 by 7, or in decimals you can write 3.14. Now here you have learned another constant, which is iota. Iota is square root minus 1. Now, what is a complex number? When do we call something a complex? Complex or compound means when it is little bit more than a single kind of thing. No, simple thing is like a sentence or a value which is complex, which has more than one type of things. So a standard complex number is written as small z, which is x plus I y, right? Small z is x plus I y. Complex numbers in general are denoted by z, and these are two numbers, x and y. Now be careful. Here are very tricky things which might be there in MCQs in your exam, and be precise about these things. X and y are real. Like this z or z is a complex number which is equal to x plus iota y, where x and y are real. What are real numbers? The numbers you have studied till now, which includes integers, rational numbers, irrational numbers. So x and y can take any value out of those real numbers. Now, if we talk about what new we have to learn, this is the partition or breakup of a complex number. This part where there is no iota present is called the real part of the complex number. We divide it into two parts, real part and this is called imaginary part. Imaginary part. See, children generally make a mistake that they write y as an imaginary number. Now, y is not an imaginary number. That's why I have written it very boldly here. X and y are real. They are nothing new, what you have learned till now. They are just those real numbers. But when any real number is accompanied by this iota, right? then it forms the imaginary part of that complex number. This is the complex number. Complex is the mixture of more than one type of thing. So there are two different parts. One is real part and the other is imaginary part. Both have real numbers. X and Y are real numbers only. But when a number is accompanied by iota, I, then it forms the imaginary part of the complex number. Z is the complex number, right? So this is the formation of a complex number. You can take example, Z is 2 minus 3 iota. Z is minus 5 by 4 plus root 3 iota. So you can use any number at the place of X and Y. All of them are real, right? So this is the formation of a complex number. So let me tell you basic operations on complex numbers. Basic operations on complex numbers. First one is addition, right? Addition. Addition is like, let Z1 be X1 plus iota Y1. This is one complex number. Other be X2 plus I by 2. So what happens if we have to add them? Z1 plus Z2 or Z1 plus Z2 is, we simply add real part to the real one and we add imaginary part. Keep I common, we take I1 plus I2, Y1 plus Y2, right? So we simply add real part to the real part and imaginary part to the imaginary part to get the sum of two complex numbers. You can take example here, minus 2 plus 3i. What is Z1 plus Z2? This is negative 2 plus 5 added to iota 3 minus 4. 5 minus 2 is 3. 3 minus 4 is negative 1. Negative 1 iota. This is only iota. Right? This way we can take the sum of these two complex numbers. Now what happens if I take the difference of them? Right? Z1 minus Z2. Here also, we simply take the difference of the real parts as well as imaginary parts. So x1 minus x2 plus iota y1 minus y2. Right? So I'm doing the subtraction here only. These are the two numbers. Z1 minus Z2, sorry. Z1 minus Z2. Now, what is the real part here? Negative 2. But here, be careful about the sign because we have to take the difference. Negative 2 minus 5. Then put plus here. Take the original signs of y1 is 3. 3 minus minus 4. We have to subtract Z2. So minus minus 4. Right? So this becomes negative 7 plus iota. What is this? 3 minus minus 3 plus 4, that is 7. So this is negative 7 plus 7 iota. Right? So this is the addition and subtraction of two complex numbers where we simply add and subtract the corresponding real and imaginary parts only. So this is quite easy. Next we have multiplication. Multiplication, like Z1 is x1 plus I by 1. Z2 is x2 plus I by 2. If we have to perform multiplication or we have to take the product of these two numbers, we write x1 plus I by 1, x2 plus I by 2. Now multiply, here you have to multiply every number with every number in the two brackets. x1 times x2 and this. x1 x2 plus x1 by 2 iota. Right? Then we have this multiplied by I times x2 y1. Then it is I times I is I square y1 by 2. right? So x1, x2. So see here, we have iota common to these terms. We can take iota common. In the standard form, every complex number is written as one real and one imaginary part, right? So we have to club all the real numbers aside and all the imaginary numbers aside and then write it in this form. So this is now iota is common here. We have x1, y2, x2, y1. What about this? Iota square. We had learned here that iota square is -1, if you remember that. Different powers of iota. Iota square is -1. So I replace iota square by -1. So now, see here, x1, x2 minus y1, y2 is the total real part, and keeping iota common, x1, y2 plus x2, y1 is the imaginary part. So this is the product of two complex numbers. Whatever the numbers are, simply take the product of every number by every number in both the brackets. Then take out the real parts aside, and the terms having iota, they can form the imaginary part. Right? So this chapter is quite easy. The basic operations are these three only, and the division we have to learn a new thing. So I hope you liked watching this video. If you have any query or you want to join classes, do contact me through our website. Thank you.